All right, let's dive in. Today, we're going to unravel one of Java's most foundational and, let's be honest, sometimes confusing keywords, static. You've definitely seen it everywhere in Java code, but what is it actually doing? Well, we're about to break it all down.
To get our heads around this, let's start with a simple analogy. Imagine a Java class is just a blueprint for a house. Now, from that one blueprint, you can build tons of individual houses, or what we call objects. Each house can have its own unique stuff, right? Like its color or the furniture inside. But what if they're all built on the same street? How does every single house know the street name without having to store a separate copy of it? That question right there, that's the exact problem the static keyword was designed to solve.
So here's our game plan. We'll start by looking at the two different worlds that exist inside a Java class. Then we'll get a solid definition for static, check out its toolkit, see why it's so important, and wrap up with a really crucial word of caution.
Okay, let's jump right into our first section, the two worlds of Java. We're going to look at instance versus class. Honestly, getting this distinction down is the key to unlocking everything else about static. You see, in Java, you've basically got these two separate worlds living side by side. On one side, you have instance members. Think of these as properties that are totally unique to each object, each individual house. The color of the house, for example. Every house gets its own can of paint, right? It's theirs and theirs alone. But on the other side, we have class members. These belong to the blueprint itself. The street name is a perfect example. It's a single piece of information shared by every single house built from that one blueprint. So that begs the question, right? How do we actually tell Java, hey, this piece of information belongs to the blueprint, not to the individual house? Well, that's exactly where our keyword comes into play. It's time to get a formal definition for static. And there it is. Static is the keyword you use to mark something as a class member. Simple as that. When you see the word static, it's a signal that the variable or the method is part of the blueprint. It exists all on its own, completely independent of any objects you might create from that class.
I love this way of thinking about it. When you declare something as static, you're not putting a little sticky note inside each house you build. Nope. You're taking a permanent marker and writing a note directly on the master blueprint for everyone to see.
All right, so we've got the what and we've got the why. Now let's get to the how. Let's open up what I like to call the static toolkit and see how you can actually put this to work in your own code.
You'll see the static keyword used in three main ways: to create static variables, static methods, and something called static blocks. Let's take a quick look at each one.
First up, static variables. This is our shared street name from the analogy. It's a single piece of data, one source of truth, that's shared across every single object of a class. This is super useful for stuff like keeping a counter to track how many objects have been created, or for defining a constant value that never, ever changes, like pi.
Next, we've got static methods. These are functions that are just attached to the blueprint. You know, a perfect example that you've almost certainly used is Java's built-in math class. You don't need to create a new math object just to find a square root, right? You just call math.sqrt. These are utility functions that just do a job without needing any data from a specific object.
And finally, we have static blocks. Now, these are a little more specialized. A static block is a chunk of code that runs exactly once, and it runs the very moment the class is first loaded into memory by the Java virtual machine, even before a single object is created. Think of it like a one-time setup routine for the blueprint itself, maybe to initialize a really complex static variable or set up a database connection.
Okay, so we know what static is, and we know the different ways to use it. But why? Why is this so important? What's the actual real-world impact? Let's cover that right now in our next section, Why Static Matters.
If you take one thing away from this, let it be this. The single biggest, most important reason to use static is memory efficiency. Especially in big applications where managing memory is everything, this is where static really shines.
This is the magic right here. When you declare a variable as static, Java allocates memory for it only once in a special shared part of memory. That's the whole point. Just one copy exists, and all the objects share it. So if you created 1,000,000 house objects, you would still only have that one copy of the static street name variable in memory. That's a huge saving. So, to quickly sum up the big benefits, it's fantastic for memory management. It lets us create those really clean, useful utility classes we talked about. And it gives us a straightforward way to have all our objects share some common piece of information.
But, and this is a big but, like any powerful tool,
It's not a silver bullet. You have to use it wisely. And that brings us to our final and very important section, a word of caution.
Let's just quickly walk through these common pitfalls. First, that shared variable is not automatically thread safe. If you have multiple threads accessing it, you need to handle that yourself. Second, if you go overboard and overuse static, you're essentially creating global state all over your application, which can make your code a real nightmare to test and maintain. Third, and this is a key limitation to remember, a static method belongs to the blueprint, so it has no idea about the unique data inside an individual house. It can't access instance variables. And finally, some will argue that using static too much kind of breaks the pure principles of object-oriented programming because you're creating behavior that isn't tied to a specific object.
And that brings us to our final thought for today. We've seen that static is an absolutely fundamental tool for managing shared data and functions. It's the essential link between the blueprint and every single object you build from it. So the question I want you to take away is this. Now that you really understand it, how is this tool going to change the way you think about and design your own Java classes?